Hi all, good morning. In the last session, we have discussed method overloading. We have discussed when the ambiguity error is possible. Uh, can you find out the solution? Okay, in this example, I illustrate the ambiguity error. For example, consider these cases: int version, float, double. Combinations of float and double and float. So in our case, when passing two integer values, int version is called. Here float, so float comma float version is called. Double comma double, the third version, this is going to be called. Passing two character variables are characters, right? C and E. Since no character version is there, character is first type promoter to integer one. Since int is there, int version is called. If no int is there, then int is converted to float. This will be called. If float is not there, then double comma double is called. Then a comma point to f. This is character comma float. So the result is float comma float. This is double comma character, double comma double. Then float comma a double. Float is type promoter to double comma double. Version is float. And 3.5 comma 25, right? 3.5 is a double quantity. 25 is an integer one. So this calls double comma double. And 10 comma 0.5 f. 10 is an integer one. This is a floating point quantity one. This invokes a float comma float version. Now finally 50 comma x. 50 comma x invokes the function. 50 is an integer one. Character is x. So int comma int version is called. Now this statement may result in ambiguity error. In what situation? When will this statement will result in ambiguity error? Ambiguity error if, can you tell me the condition when the statement say integer comma character results in the ambiguity error? What modifications do we need to do in this code? Deleting methods or adding methods? Passing integer comma character. Trying to get you. Ambiguity error. Tell me the situation when the ambiguity error is possible. No idea? Okay, what are the parameters? Integer comma character. This is checked first for integer comma int version. So assuming that int comma int version is there. If no int comma int version, let me comment out. Now what happens? Float comma float is called because int comma int is type promoter to float comma float. Again, I am converting or 1 minute. Let me comment out these methods. Starting from int version, into a float. After this type, we are commenting out, assuming that then int comma char. This is type promoter to double comma double. If double version is there. Now assuming that first three methods are not available. So in that stage, what will happen? 50 comma x, integer comma character, int not available, float not available, double not available. So type promotion rules are tested, and there is no match between the actual parameter to the type promotion rules. Now float comma double is there in one version, in another version double comma float is there. So the question is, what will happen? 50 comma x will be converted to float comma double or double comma float.
Float comma double.
Float comma double.
Double comma float.
Precedence, whether float is taking first precedence or first come left to right rule or something, how can you fix? Float comma double is executing. Why not double comma float? Or in what order the actual parameter to formal parameters are taken, please? There is no such order. Simply the values are assigned from actual parameters to formal parameters. Here there is no precedence from left to right or right to left, or from lower data type to higher type. The float is first, double is second. Right? There is no such rule. So in this case, compiler reaches the ambiguous stage whether to call float comma double version or double comma float version. That's what we will have, the ambiguity error. Java C classes 11.java. See the errors. Reference to F is ambiguous. F dot 1 comma 2. Okay, these are something, right? These errors are ignored because 1 comma 2. 1 comma 2 integer not available. Even what happens? 1 comma 2. Even that results in the ambiguous error. 1 comma 2. Right? Simply calling 1 comma 2 to float comma double or double comma float. Right? That is one kind of ambiguity error. Then this case 50 comma x. 50 comma x is converted to double comma float or float comma double. That is also one ambiguous error. Understand or not? Having any queries in this? Ambiguity is raised because the value 50 is type promoted to integer, 50 is normally integer 1, x is type promoted to integer 1, int version is not there, so it checks for the type promotion to float double or double float. Even here in the first statement itself, 1 comma 2, 1 comma 2 are integer values, right? That is an ambiguous reference to is ambiguous here. Because float or float double or double float, both are of having the rights to call the method 1 comma 2, integer to float, then integer to double. Which version is actually going to be called float double double float? That itself results in the ambiguity here. We move on to the next one. Next one is pass by value or a call by value mechanism. In C and C++, you might have studied it, call by value mechanism. What is call by value? In a function, we need to pass some parameter value, actual parameter value. Before and after the function call, we need to print the value of actual parameter. And then we need to determine what kind of actual parameters results in a pass by value or call by value mechanism. Here in Java, right, see here, the pass by value is implemented simply. For example, here one method, I defined method 1. One parameter is integer a. A is to be a formal parameter. The local variable or a formal parameter a gets updated. A is equal to a plus 10. The value of a is printed here. Then inside the main method, the object of pass by value is created. Pass by value p_obj is equal to new pass by value. One integer variable x is equal to 1000. We do want to print the value of x before and after a method call. Before method call, the value of x is printed. Then we are calling the method p_obj.method1 of x. Here x is the actual parameter. The value of x is 1000. Now the actual parameter 1000 is assigned to the formal parameter a here. What about a? A receives the value 1000. Here 1000 plus 10, 1010. Printing the value of a, right? 1010 will be printed here. Now, if you want to call, if you want to print the value of this actual parameter x, right? After the method call, what will happen? What will be the value of x after the method call? Before method call, x is 1000. After method call,
1000.
1000. Why?
call by value is 1000.
It remains 1000 because here we are passing the fundamental types. Fundamental types say integer, numeric types, then character, double types, like that, right? In that case, right, what will happen means when we pass the fundamental types as the parameter to a method definition, the changes made inside the method definition will not reflect in the actual parameter. That means here the changes are made completely in the case of a local variable or formal parameter. Since here actual parameter is a fundamental type, say x as an integer one, formal parameter is also a fundamental type, say integer a. In this case, the changes made in terms of this formal parameter will never reflect in the actual parameter which is used to make the method call. So this is to be a pass by value mechanism or call by value mechanism. To achieve a call by value, what we are doing is we need to pass the fundamental types. So before method call, the value of a is x is 1000. After method call, the same 1000 is printed, but the changes are made right only in terms of a local variable within the method definition. This is to be a pass by value or call by value mechanism, similar to the Docker, C and C++ languages. Then next one is a pass by reference. Can you tell me how a C language supports pass by reference?
Using the pointers, sir.
Yeah, using pointers. Actual parameters, right, must be the addresses of pointers, where the formal parameters must be of pointer variables. So pointer is a variable which holds the memory address of some other variable in the system memory. Since actual parameters are completely addresses, formal parameters are pointers. Pointers receive the corresponding address. So in that case, if you want to make any changes using the help of pointer names, that will also reflecting in the actual parameter, since both are pointing the same memory location. So in that case, the changes made inside the method definition or function definition will reflect in the corresponding actual parameter. That is to be a pass by reference or a call by reference mechanism. In C++, right, you might have seen the same thing, a pass by reference. In the same way, Java supports a pass by reference logic. For example, consider this class pass by reference. We have defined two instance variables x and y, and one method is defined change xy. We are passing the reference variable as a parameter to this change xy method. Pass by reference. This is a class name. POBJ is said to be a reference variable, and at the same time POBJ is the formal parameter of the method change xy. Now have a look into these assignment statements. POBJ.x is equal to POBJ.x plus 100, and POBJ.y is equal to POBJ.y something star 200. The remaining lines are commented out, just ignore it. Now this xy is a method which displays the contents of instance variables x and y. Just printed what is x and what is y. Then inside the class, say classes 13, we like to create an object of pass by ref. Say a P is one object of pass by ref. Pass by ref, a P is equal to new pass by ref. Now P dot x is set to 1, P dot y is set to 2. Since x and y are public instance variables of pass by ref, here we can set the initializer p dot x is equal to 1, p dot y is equal to 2. Then before method call, we like to print the value of x and y. So object name dot display xy, which displays the values of x and y. Then have a look into this method call statement. P dot change xy of p. In this case, what will happen means change xy. This is the method name. The method is accessible by the invoking object p. That is the meaning of p dot. P dot means the caller. Who is going to call or invoke a method change xy means the p because of p dot. P calls change xy. Then what about this p means p is also the actual parameter. P is also the actual parameter to a method change xy. So in this stage, right, what will happen means we are passing an object as the parameter to a method. So during the method call, what will happen means this kind of indirect assignment is made. Pass by ref p obj. This is the formal parameter. The formal parameter receives the value of actual parameter. Actual parameter is p. So pass by ref p obj receives a value of actual parameter of p. And again the method is invoked by the object p. So p pass by of p obj is equal to p means, right, already p is the memory allocated one, right? P is clearly an object one which is already allocated a memory. Now p obj is a reference variable. When a reference variable assigns an object of the same class, that reference variable becomes an alias of that object. So p obj is an alias of an object or actual parameter object p. Hope you understand clearly. Now, since this is a method definition and p obj is not only a reference variable but also a local variable. So you can access the memory location of p using its alias, say p obj. So within this method definition, p cannot be directly accessible, but its alias p obj is accessible. P obj dot x is equal to p obj dot x plus 100. Then p obj dot y is equal to p obj dot y star 200. This means that p obj dot x is indirectly, right, p dot x, because p is the p is the actual parameter. Actual parameter alias is p obj. P obj dot x means this will also be reflecting in the actual parameter p dot x. This means p dot x is equal to p dot x plus 100. Likewise, the second statement is equivalent to p dot y into 200. P dot y is p dot y into 200. So the changes made inside the method definition in terms of the formal parameter will reflect in the actual parameter which is used to make the method call. So ignoring the next two lines, right? Next, coming to the main method, after the method call, we do like to print the value of same x and y, p dot display xy. Here p dot display xy prints x is equal to 1, y is equal to 2. After the method call, what will happen means this p dot display xy updates the values of these changes made inside the method definition. Understand or not? So changes made inside the method definition will reflect in the corresponding actual parameter. If it's so, then it is said to be a pass by reference. So to achieve a pass by reference, what we have to do is we need to pass objects as parameters. Passing objects as parameters, we can have certain changes inside the method definition. That changes are automatically reflected in the actual parameter object. This is a logic of pass by reference. The same concept is supported in C++. You can pass objects as a parameter to a member function. So changes made inside the member function will reflect in the corresponding actual parameter, that is call by reference or pass by reference. So have a look into this output. Before method call x is 1, y is 2. After method call x and y are updated. Right?